Here we have made a kit in which we can control appliances through a laptop. So we have a connector here which is connected to the USB port of the laptop, and through this connector we can control 4 appliances. As you can see, we have used 4 bulbs here, and we have programmed the kit in such a way that 1, 3, 5, 7 and 9 will turn on the bulbs, and 2, 4, 6, 8 and 0 will switch them off. So we'll just show you a demo. So as you can see, this is how the kit works, and you can order this kit from our website kitsguru.com, where you will get 2 versions of the kit. One is where you will get this complete ready-made kit which you can see here, and the other one is where you will get all the components separately, and with the help of our video tutorials you will be able to assemble the components and complete the set by yourself. In this section of the video, we'll see what all components are used in this kit and how this kit works and what are the functions of each component, and then how do we assemble all the components into a ready-made or complete working kit. So before that, we'll understand how the kit works. So here there are 2 PCBs, as you can see. One is the main PCB of the microcontroller, and the other one is a relay driver PCB. So first we'll understand the main microcontroller kit or circuit. So this is the power supply input. As you can see, the power jack from where we can give an input of 12 volts from the adapter. Then there's an on-off switch which controls the power supply to the kit. Then this is a bridge rectifier in case you are giving a power supply through a transformer. You have to convert the AC supply into DC supply. For that we use a bridge rectifier. And this is a capacitor, electrolytic capacitor, which removes all the repulses from the DC signal. And this is a parallel power supply. That means when the relay driver needs supply of 12 volts DC, so we have given a parallel connection here. Voltage regulator IC is used because all the components in this kit works at 5 volts. So we need to convert the input DC into 5 volts output DC. And then this is a 40-pin microcontroller. So we have to connect this particular USB drive to a laptop and then provide the signal. So these are the data pins from where the signals, one is ground, one is the positive signal, and one is data. So here is the data which is received, and then it is sent to the microcontroller, which processes the data, and then the output of the microcontroller is connected to this relay driver circuit. So as you can see, the 4 pins, these are the output, one for each relay. And then crystal oscillator is used because the microcontroller works on a clock frequency. A micro switch is used to reset the microcontroller. A resistor is used to pull up the micro switch. Then network resistor is used to pull up the output of the microcontroller. It is a cluster. This is a cluster of 8 different resistors of 10 kilo ohm each. So this completes this main microcontroller PCB. And then as you can see, we have given a power supply here. So this is a ULN driver IC which is used to drive the relay. So this is a high current IC which supplies high current to relays. And then these are the power indicators. I mean, whichever relay is on, corresponding to that, the particular LED will glow. And along with that, we give a resistor of 1K to protect the LED. And here you can see there are 4 pins. So 2 pins are for the AC input and 2 pins are connected to the bulb. So as you can see, we have connected the input AC supply of each bulb commonly. We have combined them into one. And then the output supply from the relay to the bulb is connected to each corresponding relay, as you can see. So whenever the output is received here, the output is received by the ULN, and it gives the current to a particular relay. So whichever relay gets on, that particular bulb gets switched on in case the AC supply is present. If there's no AC supply, then only the relay will get on and the bulb will remain off. So now we will see how to assemble the kit. So first we'll assemble the relay card. So this is a blank PCB. So this is the top layer and this is the bottom layer where the copper tracks are present. The technology that we use is called a through hole technology, in which we drill holes from the top and then insert components from the top and solder the components at the bottom. So we have ready-made kits here. So I'll keep my blank PCB in line with the ready-made PCB in order to understand the alignment and orientation of each component. So first we'll insert a 2-pin connector for this power supply, and then a diode. A diode is used for polarity protection. In case you give the power connection in the reverse polarity, diode will rectify it. So as you can see, there is a gray strip on the diode. There's a gray strip on the diode, so that gray strip has to be present on the left side. It means the power supply is flowing from the positive end to the negative end. And then this is an IC base, a ULN IC base. So before inserting an IC, we use a base in order to protect the IC during soldering, or in case you need to replace the IC in the future, you can do that easily. So this is an IC, and you can see there's a notch on this IC. So the top left pin, the left pin from the notch is the pin number 1, and then you need to count the pins counterclockwise. So this is a pin number 9, 10, and then this is a pin number 18. So this is how the pin is counted. So before inserting the IC, we'll insert the base. Even the base has a notch. So as you can see, the notch is on the bottom side, it's facing you. So we'll insert the first IC base, and then we'll keep the IC on top of it. And then there's a 4-pin connector base, which is used to receive the output signal from the microcontroller. And then a relay. These are 4 relays. So you can insert all the relays in this way. And then an LED. Even LED has polarity. So the stem which is longer in length is the positive stem. In case both the stems are of equal length, you'll notice that the bulb is round in shape, but at the negative end it gets flat. So while inserting the LED, we'll make sure that the negative end is away from us, and along with the LED we give a resistor of 1K for protection. The 1K resistor has a color code of brown, black and red, so you'll have to make sure of that. So you can insert rest of the relays like that, in the same way, the same orientation. And then another 4-pin connector here to take the output from the relay to the bulbs. So 2 for the AC input and 2 for the DC output, the output. So this is how you need to connect the components onto the relay card. So once this is finished, we'll move on to the next PCB. So I'm keeping this also in corresponding with the ready-made kit. So first the power jack, then the 2-pin base is not necessary. So then we'll insert this on-off switch. This does not have any polarity. And bridge rectifier. So the bridge rectifier has 4 terminals, 2 AC input and 2 DC output terminals. So the AC input is represented by the AC signal, and the DC output is represented by the positive and negative sign. So the stem which is longer in length is the positive output terminal. While inserting the bridge rectifier, we need to ensure that the positive terminal is in the bottom left side. So the positive terminal is the bottom left side, and this is an electrolytic capacitor. Even this has polarity. The stem which is longer in length is a positive terminal. In case both the stems are of equal length, the capacitor has an indicator which shows that is a negative terminal. Now the positive terminal of the capacitor should be in line with the positive terminal of the bridge rectifier. So you'll be facing the positive terminal, and then a 2-pin connector in order to give a parallel power supply to the relay card, and then a voltage regulator IC, because all the components work on 5 volts. So this is a voltage regulator IC 7805. So this left pin is the pin number 1, that is the input pin. Then center one is a ground one, and the third pin on the right is the output pin. So while inserting, we have to ensure that the input pin is in line with the positive terminal of the capacitor, and then a power indicator LED here. So a power indicator LED, the negative end will be on the right side. Along with that, the resistor of 1K. So this completes the section of the power supply. Then we'll move on to the microcontroller section. So this is the 40-pin microcontroller base. So the notch is on the bottom side, as you can see here. So we'll make sure that the notch is on the bottom side. And this works on a clock frequency, so we'll insert this crystal oscillator of 16 MHz. This does not have any polarity. Along with that, to start the oscillation process, we use 2 capacitors of 33 picofarad each in parallel. Then a micro switch is used to reset the microcontroller, and this does not have any polarity. Along with that, we use a resistor of 10K with color code brown, black and orange to pull up the microcontroller. Even resistors don't have polarity. So then another 4-pin connector, as you can see here, 4-pin connector to connect the USB drive to the laptop to receive the signal, and then another signal detector LED here. So while inserting this, we'll make sure that the negative end is facing towards us, and another resistor of 1K. Then a network resistor is used to control the output of the microcontroller. So a network resistor is a cluster of 8 resistors of 10K each. You'll notice that there's a dot on the main strip, the front strip. So while inserting, we make sure that the dot is towards our side. And then we'll connect a 4-pin connector base for giving the microcontroller output to the relay card. So this completes the assembly of the components. So now, before moving on to fixing the ICs, we'll first check the power supply. For that, we use a digital multimeter. So this is a digital multimeter. The black terminal is the common terminal, which is connected to the body of the voltage regulator IC. The first pin should show the input power supply. The third pin should show 5 volts. 40th pin of the microcontroller should show 5 volts. So this is the pin number 1 of the microcontroller, and counting counterclockwise, this is 40th pin, should show 5 volts. Here, while giving the parallel power supply, we have to ensure that the positive is connected to the positive. So this is the positive power supply, this is the ground. So this is towards the outer side here. Here also we'll have to make sure that the outer part is the positive supply, and then the inner part is the ground. And at the diode, we'll check the power supply. It should be the input power supply at the diode, as you can see. Then while connecting the USB drive, as you can see, there are 3 terminals. So one is ground, and one is the RX, and one is the TX. So at this USB drive, you will see that there's ground, then there is RX, and then there is TX. So while connecting, we have to ensure that first you connect the ground, then TX to RX, and then RX to TX. So this is how the connection is done: ground, TX to the RX, and RX to TX. And Then you have to make sure that the 4 terminals corresponding to each relay, 2 are connected to the AC signal and 2 are connected to the output to the bulb. So when you connect the power supplies, you'll have to make sure that it is getting the proper power supply here. 2 are getting a power supply from the AC, and then the other 2 are getting the AC output to the bulb. So these connectors, they do not have any polarity in particular. They can be connected in any way. This is just for the output of the microcontroller. So once the power supplies are checked, you can move on to fixing your ICs and completing the kit. So you can order this kit from our site kitsguru.com, where you'll get 2 versions of the kit. One is where you'll get the complete ready-made kit, and the other one is where you'll get the set of components separately, and with the help of our data and material and video tutorials, you'll be able to assemble all the components and complete this kit by yourself.